All right, now we are going to introduce that value that I mentioned before, the comparison of P to some value. This value is that alpha, all right? And it is indeed the same alpha that's the probability of a type 1 error where we reject the null hypothesis when the null hypothesis was actually true. What we call this this alpha value when we're referring to comparing it to B is we'll call it the significance level. Significance level. And also remember, just while we're talking about alpha, alpha was that same value back in chapter 8? Was that only last chapter? I think it was actually the very beginning of chapter 8 where we had the normal curve and we were looking at the confidence level compared to alpha being split in two sides. It is that same alpha. So if you're running a 95% confidence level, that means you have a 5% level of significance. All right. This relationship holds up where the confidence level and alpha are complements of each other. Together, they add up to 1 or 100%. Again, I've said this multiple times now within this chapter, within these videos, but rejecting the null hypothesis does not mean that the null hypothesis is true. Sorry. Failing to reject the null hypothesis does not mean that the null hypothesis is true. It just means we have an inconclusive result. We don't have sufficient evidence to support our alternative. The ideal situation is that we do successfully reject the null hypothesis because then the alternative is true. Let's go ahead and look at this first example. We're not calculating the p-value here. It's already going to be given to us, but we're talking about that It's a Boy genetics lab claiming their procedure improves the chances of having a boy. So they're trying to show, hey, the proportion is more than 50%, where it's pretty well known that, hey, the proportion of having a boy or girl is exactly 50%. 50-50 chance. All right, let's say we do run this test. We get the p-value of 0.025, and we're running it at a 99% confidence level, or we have a level significance of 1%. That's the alpha. Right, so to make the conclusion, you have to compare p and alpha. All right, our p-value was 0.025. Our alpha was 0.01. And I'm writing this way because I'm going to write an inequality between them. Which is bigger? All right, 0 and 0 for that first placeholder. So we're tied. We go to the second placeholder and we have a 2 compared to a 1. The p-value is bigger here. All right, p is bigger than alpha. So if the p is high, what was our rhyme? It means the null is fly. When I ask you these things, what I'm looking for in an assessment is for you to do a couple things. Make this comparison, make a conclusion, and when I call or a decision, make a decision. When I say decision, what I mean is, do you reject H naught or do you fail to reject H naught? Here, P is high, null is fly. That means we fail to reject H naught. That's what I call the decision. All right, and that is very generic. So then we make a conclusion where we take this we fail to reject H naught and we relate it back to the actual context of the problem. So our conclusion is actually an inconclusive result. Because we failed to reject H naught, it doesn't mean that HA is necessarily true, doesn't mean that it's false. It just means we didn't have enough evidence to support that HA was true. Your conclusion should always discuss HA, the alternative hypothesis. And this is because we place in HA the thing that we're actually trying to show. Here they were trying to show that the procedure improves the chances of being a boy, that the proportion is greater than 0.50. They put that in the alternative hypothesis. Yes, the decision talks about H naught, but by disproving H naught, you prove that HA is true. By failing to disprove H naught, you don't know anything new about HA. So here our summary is going to be that there is insufficient. And this is a general way to describe any situation. There is enough evidence, there is not enough evidence. There is sufficient evidence, there is insufficient evidence. Here, there's not enough evidence because we failed to reject H naught. So there's not enough evidence to support. And here's where we describe what our alternative hypothesis was. I'm kind of leaving, I'll put blanks under. The rest of this is a general statement that you could copy and paste for every summary. There is blank evidence, either sufficient if we were able to reject or insufficient if we were not able to reject, evidence to support. And here's where we have to fill in our alternative hypothesis. In our case, it was to support that the test or the procedures actually improve the chances of having a boy, to support that the procedures improve the chances of a boy being born. All right, additional notes. If there is no level of significance given or no confidence level, see, I did write it on here somewhere. I wrote this up at the top again. If there is no confidence level or level of significance required or provided, this is a good level of significance to just go with. A 95% confidence level or a level of significance of 5% is safe and a pretty standard value to compare our p-value to. I won't be really giving you any where it's not provided, so don't expect to use that a lot, but just in general, just for your knowledge, if it's not provided, 5% level of significance is a pretty good standard to go by.